It's Sunday. You know what that means. 6-cycle oddball build series video number 17. We're going to call this the final 0.5 because I intended to have this engine running in this video, but I'm an idiot and I burnt out my ignition. So that was $65 down the drain. Unfortunately, it happened. I don't know how to fix it. It's covered in that potting compound that they use on circuit boards. I don't think I can repair it. I ordered a new one. You're going to have to wait till next week to see if it runs. I don't know if it runs. You definitely don't know if it runs, but we'll find out together next week. Sorry about that, albeit it is what it is. For the future, I'm curious what day of the week is best for you to tune in and watch one of my videos. YouTube Analytics says Wednesday is the best day to release a video, but I have quite a few pretty loyal followers here, so I'm curious what works best for y'all. Sunday doesn't really work all that well for me, albeit I could probably continue to make it work. I'd rather not, though. So if Wednesday works for everyone, that's when I will probably start releasing videos in my next series, which I don't really know what it's going to be yet. If anybody has any ideas, put all that in the comments down below, and I'll do my best to accommodate what anyone wants to see. With all of that said, thanks so much for watching. Please don't forget to subscribe. This is unfortunately a bit of a hodgepodge of pieces here at the end, kind of all the little stuff coming together to get this engine complete. This will be the final build series of this 6-cycle oddball build series. I'm sorry, this will be the final machining video of the 6-cycle oddball build series. So hopefully you enjoyed all of this. I definitely enjoyed doing it. I enjoyed the interaction in the comments down below, and we'll see what the future has in store. I don't know 100% what I'm going to do yet, but it'll be something fun, it'll be something exciting, and most importantly for you, it'll be something entertaining. Thanks a lot for watching. Don't forget to come back next week to see the final video of this series. Alright, so we have to make this camshaft right here, which is only used to open and close the exhaust valve. The intake valve works off of suction. I'll show you more how this all works when the engine is final assembled. But as you can see, it's a kind of not conventional cam lobe shape. It's 218 thick. And Mr. Joe came up with a really clever idea to make this out of 2 separate pieces, which I'm going to try and do. I don't know if it's going to work or not. Seems like it worked in his video. But basically, this piece is the inner radius, and then this piece is the outer radius. I think you can see those 2 scribe lines on there. What I'm going to do is cut these 2 scribe lines, clean it up really well, and then try and silver braze this together. Then what this is going to look like on our cam gear, it's going to be together like this, and that's going to be the cam. This is of course going to be out here. I don't want to push it all the way on because it's a pretty tight fit, but that should create our cam lobe. So I'm going to get this sawn up and get it soldered, and then I'm going to come back when this either worked or didn't work. I'll either show you it working or I'll show you that it didn't work for me at all. But in theory, it should work. I guess the ideal solution to this would be to cut this on a rotary table with a round end mill, right? You would do 171.5 degree sweep. But my only problem is my rotary table has a good bit of backlash in it, so I don't think I can do that super accurately. I've tried cuts like this in the past and it hasn't worked out well for me. So I'm going to give this a try first. It was just a matter of turning these 2 rings up on the lathe, which was pretty easy. Literally 2 metal rings, you know, nothing to that. And I'm going to try this first. If it doesn't work, oh well. Then we'll try the rotary table as the plans specify. But let's give this a try. So here's what you end up with for the cam lobe. And then this of course fits into our gear piece like so. However, whenever you lay it onto the print, looks pretty darn good. Probably not 110% perfect, but I cut another one. This was the first one, and I cut it wrong. So it ended up not working, but we have what we need now. So I think we will be good to go when I lay this all together onto the print. Get it lined up with the hole here. That sure looks like it's going to be the cam lobe. I do believe that's going to work just fine, which is awesome. I'm going to silver solder this and we'll go from there. With any luck, that will be our cam. Well, there it is. I used way too much silver solder, but I think we got a good strong joint on it. I am going to clean this up with some sandpaper and my belt grinder, and we'll see how it looks when it's all said and done. But I think that's a camshaft if I've ever seen one. Now we just got to see if it's going to work. So here at the end I'm going to make these, what are they called? Governor weight arms. I'm not going to video a whole lot of it. It's a really straightforward piece to make. This little dimple here at the end, I'm probably just going to barely hit that with a little tiny end mill and then use the belt sander and make that round. But that looks super complex, but it's literally 2 holes, turn the end of it round in the 4-jaw chuck, which you'll see me do that, and then cut these 2 in half and kind of finish them up with a file and stuff. But like I said, it looks complex. It's a super easy part to make. And you know, I literally cannot show you every single thing that I do, or this is going to go on forever. One thing that I will say, this 3/16 diameter hole, it says right here to break the corners. That's going to have a spring, a long spring passing through that. So I used the deburring tool. You can probably somewhat see it there, to break the corner real good. And that's just to keep the spring from getting snagged in that hole. That's the only reason that's there. But yeah, pretty easy part to make. Like I said, I'll show you turning down one of these pieces on the end, and then I'll bring you back when it's a finished product. So that means now we get to do one of my favorite operations on the lathe, which is making something that is square into something that is round. I just feel like it's really satisfying whenever you do that. So that's what we're going to do. Need to get set up here for an end stop. Got this part dialed in close enough. We're within a thou and a half, which is just lovely. There's my setup. I do this all the time. A center stacked with a center and a punch mark on the end of the part. I think that's the easiest way to dial in a square part in the lathe. So the round is turned, looks like 11 30-seconds long. That's kind of an oddly specific amount. 11 30-seconds is 0.344, we're going to call it. So one, I've got my hard stop a little close here. 2, 3, 44 is right there. Get my stop set up over here so we can just keep bouncing right into that. All right. That's probably a bit fast. Here goes nothing. Like I said, making a square peg fit in a round hole. There we go. Round peg for a square hole. Like I said, one of my favorite operations to do. Alright, well, there's our little piece. It's got the little hook on the back. I may have used an end mill and went a little bit too deep on that kind of rounded hook on the back. But that's gonna be in here like this, and it needs to be able to pivot. So hopefully we did okay there. Worst case scenario, I'll remake it. This is the spool that's going to pull the governor open and closed. And then I made these little governor weights, and I'm going to solder them into there. And that'll pretty much be the extent of the governor. These are the pins. I still need to drill some cross holes in those for a cotter pin. These were pretty fun to make. They're super small. But got them done. So overall, here's what we have.